Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS3551 Distributed Computing. The unit is Consensus and Recovery. In this video, we are going to discuss about coordinated checkpointing algorithm. CoToF coordinated checkpointing algorithm. This is a coordinated checkpointing and recovery technique that takes a consistent set of checkpointing and avoids domino effect and livelock problems during the recovery. It includes two parts. First one is the checkpointing algorithm, then second one is a recovery algorithm. The checkpointing algorithm makes the following assumptions about the distributed system. The assumption is the FAFO channel, end-to-end protocols, communication failure, do not partition the network, single process initiation, no process fails during the execution of the algorithm. There are two kinds of the checkpoints. First one is a permanent, then second one is a tentative. Permanent checkpoint means local checkpoint, part of a consistent global checkpoint. The tentative checkpoint means temporary checkpoint became permanent checkpoint when the algorithm terminates successfully. The checkpointing algorithm has two phases. First one, in first phase, the initiating process at PI takes a tentative checkpoint and requests all the other processes to take the tentative checkpoints. Each process informs PI whether it succeeded in taking a tentative checkpoint. A process says no to a request if it fails to take the tentative checkpoint. Suppose if the PA learns that all the processes have successfully taken tentative checkpoints, PA decides that all the tentative checkpoints should be made permanent. Otherwise, PA decides that all the tentative checkpoints should be thrown away. Next one is the second phase. In the second phase, PA informs all the process of the decision reached at the end of the first phase. A process on receiving the message from PA will act accordingly. Either all or none of the process advance the checkpoint by taking the permanent checkpoints. The algorithm requires that after a process has taken a tentative checkpoint, it cannot send the related to the basic computation until it is informed of PA's decisions. The correctness of this algorithm for two reasons. Either all or none of the process take the permanent checkpoint. Then second one is no process sends the message after taking permanent checkpoint. Optimization. The above protocol may cause a process to take a checkpoint even when it is not necessary for consistency. The rollback recovery algorithm. The rollback recovery algorithm restores the system state to a consistent state after a failure. The rollback recovery algorithm assumes that a single process invokes the algorithm. It assumes the checkpoint and the rollback recovery algorithms are not invoked concurrently. The rollback recovery algorithm has two parts, two phases. First phase is an initiation process. PA sends a message to all other processes to check if they are willing to restart from their previous checkpoints. Suppose if it is means a process may reply no to a restart request due to any reason. If PA learns that all processes are willing to restart their previous checkpoints, then PA decide to all the processes should roll back of their previous checkpoints. Otherwise, PA abort the rollback attempt and it may attempt a recovery at a later time. The second phase is that the PA propagates its decision to all the process. On receiving PA's decision, the process acts accordingly. During the execution of the recovery algorithm, the process cannot send any related messages to the underlying computation while it is waiting for the PA's decision. The correctness of the particular algorithm is a resume for a consistent state. The optimization of this algorithm is may not to recover all since some of the processes did not change anything. This is the diagram for the rollback recovery algorithm.